Video, we're going to show an example of simplifying fourth roots. To do this, I'm going to use the following property, where you can split up the product of two numbers into two separate nth roots. By the way, you can do it with multiplication or you can do it with division, but you cannot do it with addition and subtraction. So these are the only two properties from this section. Okay, so what I'm going to do is realize that 3 goes into, or maybe 9, because there's a 9 here, goes into 729. In fact, I think it's 81 times, because 81 times 9 is, yep. So this turns out to be the fourth root of 81 times 9. Let's see if 9 goes into 144. You can also divide. Let's do it that way. So that would be 1. 9, 5 times, so that would be 16. So this is 16 times 9. I got the trick because there was a 9 there. But you could make a tree on this and do this the long way. Also, the fourth root of 81 is perfect, and the fourth root of 16 is perfect. So these are two great factors to use. Let's go ahead and just rewrite 5 times the fourth root of 9. Okay, and I'm going to erase my little scratch and talk about perfect roots. The fourth root of 16 is 2, because 2 times 2 times 2 times 2, that's 4 times 4 is 16. By the way, the fourth root of 81 is 3 for the same reason, because 3 times 3 times 3 times 3 is equal to 9 times 9, which is 81, which is what we're going to do, because we're going to split this up into two separate things. This is the fourth root of 81 times the fourth root of 9, using my property. Let's rewrite this the same thing, the fourth root of 16 and the fourth root of 9, with the same property. Let's leave this one. Okay, and what did I just say the fourth root of 81 was? Let's do that in a different color. The fourth root of 81 is 3. So we have a 7 still, times a 3, times the fourth root of 9. Same idea here. We know the fourth root of 16 is 2. So we'll leave the minus and the 3, and we'll call the fourth root of 16 a 2. And we'll leave the fourth root of 9, and let's not change anything on the last one. So what this becomes is 21 times the fourth root of 9 minus 6 times the fourth root of 9 plus 5 times the fourth root of 9. And if I add, all of these are now the same square root, and if I had 21 of something minus 6 of something, that is 15 of that same something. Bringing down the 5 times the fourth root of 9 and doing the same thing, we have 15 of something plus 5 of something is 20 times the fourth root of 9. This is a fine answer. It turns out the computer did not put this answer, but I will accept this for full credit. What they did is they realized that the fourth root of 9, let's talk about the fourth root of 9. The fourth root of 9 is the same as the fourth root of 3 squared. And we can rewrite this in the third property in one of these sections. If you had m over n, we know that's the nth root of a to the m. So going backwards here, we're going to say that's 3 to the numerator is the 2, and the denominator is the index, which turns out to be 3 to the 1/2. Now going forwards again, that is index 2, the square root of 3 to the 1. But when the index is 2, it's just called square root, and you don't need to write a 1, so it's just square root of 3. So book has this, or the computer has this, as 20 times the square root of 3. That works also. Again, on any test, I would accept both answers because 9 to me is a perfect answer in terms of fourth roots. You cannot, there's no perfect fourth root of 9, so you can't simplify that further, but you could change it to square roots just because the 9 was 3 squared. Hope that helps.